I'm walking in to Rajasthani. It's a traditional Rajasthani cuisine restaurant. You will get to see one of India's cuisines. It has 28 states, and each state has its own cuisine. And here we explore different types of cuisines with our ISRO colleagues and friends. We are waiting for the traditional lamp lighting ceremony, what we call the diyas. And the background music that plays is really world peace and happiness prayer. It was so soothing, and it was such a positive energy here. I wish you could all witness this. Thank you for joining me on this tour of my city. I hope you enjoyed it as much as I did. I can't wait to see the launch and operate this amazing observatory.
Sue, you also traveled to India for this mission.
Yes, I did. It was really an amazing experience. It was my first trip to India. I went in February of 2020 to meet with the science team in India, and again a few years later.
And, you know, speaking of travel, NASA leadership is on the ground right now in India getting ready for launch. Here's what they had to say.
I'm here in India, super excited as we are here to support our NISAR mission as it takes to the skies. And today, it's all about NISAR.
It's an exciting week for NASA. We have our Crew 11 launch in Florida, and we have our NISAR launch here in India, which is where I am with our NASA teams. Super excited to be here, an incredible collaboration between India, the United States. This launch really represents the culmination of over 10 years of collaborations between our two countries. So go NASA, go JPL, go ISRO, go NISAR.
I'm here today at IIT Madras for the pre-launch science team meeting for the NISAR mission. We are learning all about the terrific science that's going to come out of this mission. I just heard about how NISAR will revolutionize our understanding of how earthquakes happen around the globe. The excitement for launch here is palpable, and I can't wait to get back inside and hear more.
Go NISAR indeed, and to help us better understand the spacecraft, you have brought a model with us.
Yes, so here we have a model of the NISAR spacecraft. You can see here we have solar panels to power the spacecraft. Here we have in this octagonal structure, this is the radar instrument structure, or the RIS. So the L and the S-band radar are housed here. And then behind that is the spacecraft bus, which houses the power and the telemetry and other key functions of the satellite. Then attached to that is this impressive boom that holds up the nearly 40-foot in diameter gold reflector antenna reflector of NISAR.
And so it is not going to launch in this configuration, right? It has to be packed up. So how does that work?
So right now it's all folded up and stored and ready for launch. And so the way that it folds up is this boom actually wraps around the radar instrument structure, but first the antenna reflector folds up. So it kind of collapses like an umbrella or a camp chair, and then it's stored underneath the radar instrument structure in this configuration, and it's held in place by this little latch down here.
Well, that is exciting stuff. Thank you so much for the breakdown, Sue. So NISAR is a joint mission between NASA and ISRO, but that is just one example of how our two countries are working together in space. So here's more in your Artemis Moon Minute. NASA's Artemis campaign uses missions on and around the moon to prepare for future human missions to Mars and highlights a new era of international cooperation championed through the Artemis Accords. Established in 2020 by the United States, led by NASA with the U.S. state precisely locating targets on the moon could help guide Artemis astronauts to the surface in the dark or mark the locations of spacecraft already on the lunar surface, so astronauts or uncrewed spacecraft can land near them. As of today, over 50 nations have signed on to the Artemis Accord. NASA and Axiom Space's AX-4 mission. NASA and Axiom Space's AX-4 mission. Shifting gears back to NISAR, the Earth Observing Satellite. Shifting gears back to NISAR, the Earth Observing Satellite is set to give scientists a clearer view of how ice is moving, melting, and reshaping our world. Here to tell us more is Eric Rignot. Thanks for being here today.
You're welcome.
So how can NISAR help us understand how tracking melting ice from glaciers and ice sheets is important?
NISAR will track the motion of glaciers and ice sheets and combine with information from climate models and thickness of the ice, we can figure out how much they contribute to sea level rise. And glacier melt is one of the main contributions to sea level rise. We need this information to inform society on how to protect ourselves from sea level rise. And then the scientists will be able to use this information in climate models to project what sea level would look like in the next few years, in the next decades, in the next century, so we can better protect society and save human lives too.
Very important information.
So Eric, can you tell us how will NISAR help us see changes in the ice that are difficult to detect from the ground?
Yeah, so the NISAR will cover the globe in 12 days, and in particular it will cover all of Antarctica for the first time. And conducting these measurements in the Antarctic would be nearly impossible for ground parties because the continent is so vast. It's larger than the United States, and it would put these field teams in great danger if they had to do this work continuously on the Antarctic. So with NISAR, we'll have this information continuously about what's happening in the Antarctic. If there's any important event, we'll see it, we'll catch it, and it will be part of public knowledge from this data.
Thank you, Eric. That's great.
Eric, that was really important information. Thank you so much for joining us today. And let's take another look into mission control here at JPL. Where the team is excited to watch launch. And just a few days ago, I had a chance to speak with Dave Gallagher, the new director of JPL, to hear his thoughts on launch. Dave, thank you so much for joining us today.
It's my pleasure, Raquel. I'm happy to be here.
From your perspective, why is NISAR such a groundbreaking collaboration between NASA and ISRO?
This is the single biggest collaboration in space between the United States and India. It's enormously important to both countries, and space diplomacy is key right now. One of the most challenging things about this collaboration is the difficult time zone. So we have our JPL engineers and scientists working shoulder to shoulder with their ISRO counterparts, and the team is just working fantastic together.
When people think of JPL, they probably think of Mars rovers or deep space exploration, but JPL is also dedicated to studying Earth science and our home planet. What do you hope NISAR will achieve that adds on to those many Earth missions?
Well, Raquel, just to build on what you said, We actually have 4 decades of pioneering missions to really understand our home planet, missions like GRACE. Of radar. The L-band radar is The L-band radar is developed by JPL. The S-band radar is developed by ISRO, and that combination of those 2 radar systems will allow us an unprecedented understanding and view of the Earth. NISAR builds on JPL's long-standing legacy of working with international partners. We can drive innovation when we take advantage of each country's strengths. We are actually stronger when we work together than doing this alone.
So looking ahead, what kind of legacy do you hope NISAR leaves behind for future Earth science missions?
What I'm most excited about with NISAR is the real-world applications, things like infrastructure monitoring, natural disaster recovery and response, agriculture management. This is going to make a real difference for real people around the world.
Thank you so much for your time and insights today.
Thanks.
As a reminder, this is a joint broadcast, and we will hand it over to ISRO, who will cover NISAR's launch, which is just about 36 minutes away. And Sue, we have another social media question coming in. So Pradeep on
Innovation from NISAR is the dual band radar.
NASA has more than 24 missions focused on Earth science right now. What makes NISAR unique?
We really don't quite understand why our planet is always moving. The surface of the planet is always kind of moving, and we can't detect it. But with this amazing technology that NISAR brings, we're going to be able to actually start studying these tiny little, almost landslides, these little tiny quakes. And the goal, of course, being that we find a signature that happens before a major disaster that would allow us to then look for that and search for it and almost be able to predict these big disasters before they happen.
And you mentioned those tiny changes that this mission will track. What kind of other insights may we gain that could help people in their everyday lives?
We're also getting the data into the hands of people that need it, the decision makers, the people who are working with the first responders to actually go in and help people once these disasters have happened. You mentioned how many missions we have in the Earth Science Fleet. And, when you put all these missions together, you just get so much more out of them. And so having NISAR launch take its place in the Earth Science Fleet, really illuminating so much more about our home planet, NISAR is just going to give us unprecedented views to add to the information we have about our planet.
And Nikki, we are so close to launch. So what are you looking most forward to right now?
Oh my goodness. I love a good launch. I'm not going to lie. I'm a launch junkie. I love everything about them. But really it's that final sort of when you get to that final countdown and, you just appreciate, for me, being with the team, being with this combined team who've worked so hard to make this happen. I know I've been on mission teams and it's almost like you're sprinting to the start line as a scientist. You've done all the work. The mission is there. It's on the rocket. Once it launches, all of the science begins.
Fantastic. Thank you so much for joining us today.
Thank you so much. Go NISAR.
And Sue, we have more social questions coming in, so why don't you answer some more? We have Ayush on YouTube who wants to know, how long will it take to get NISAR fully running?
So that's a good question. So it will take about 90 days before we start collecting, before the science mission starts and we start collecting science data. So in those 90 days, we will be deploying the satellite, deploying the boom and the reflector, as well as testing out all of the radar instruments and making sure that everything is calibrated and validated initially correctly.
So 90 days from now will be like Christmas for you.
Yes, it will.
And Rian on YouTube wants to know, how will ISRO and NASA ensure NISAR's data is accessible and useful for developing nations most affected by climate change?
Oh, that is a wonderful question. So NASA has an open science policy, an open data policy, and so all of the data that NISAR will be collecting, all of the L-band data will be available through a NASA archive at the Alaska Satellite Facility, and then India will also be making their data available, the S-band data and L-band data that they will be processing available and openly free and available to everyone through their data archive as well. So all of the data will be free.
Great, and we have a couple more coming in. Raul on X wants to know, why is NISAR's antenna so big compared to other Earth-observing satellites, and what is it made out of?
So I can answer the first question. I don't think I have the exact facts for the second question about what it's made of. But the reason why it needs to be so large is that area gives us the very high spatial resolution that is going to be unique to NISAR, combining that global coverage as well as the high spatial resolution. So we need that surface area to collect all the reflected radar signal from the Earth, focus it onto the receiving antenna, and that will give us the high spatial resolution.
Thank you, Sue. So Anjin018 on YouTube wants to know, since NISAR uses both L-band and S-band SAR, how does the dual-band radar improve surface imagery accuracy, especially in densely vegetated and urban regions? These are some great questions.
Yeah. So how will the L and S-band radar help us improve the surface deformation?
Vegetated and urban regions.
Vegetated and urban regions. So that because the two different radars are different wavelengths, they will be sensitive to different parts of the vegetated environment, and so we'll be able to characterize the vegetated areas more accurately using the two different wavelengths.
Really appreciate your expertise, Sue. Thank you so much, and thank you all for your questions. So Sue, launch is just 30 minutes away, so tell us how much this moment means to you and the NISAR team.
This is so special. I've been working on NISAR, been part of the team for over 10 years. I know people have been working on this mission concept for decades. And so it's really an amazing moment to finally be here at launch. And we're just so excited to be starting the science observations, to start collecting the data. It will be so impactful for so many people on the planet.
Great, Sue. So we will now take you to the Satish Dhawan Space Center in India for coverage of liftoff in about 30 minutes from now. Remember, NISAR is a joint mission between NASA and the Indian Space Research Organization, or ISRO. Part of ISRO's coverage will be in Hindi, but we will be having an interpreter providing English translations so you can follow along. And we will see you again after liftoff.
Mission intends to place the NISAR satellite weighing about 2,400 kilograms in 747.4 kilometers circular polar sun-synchronous orbit with an inclination of 98.4 degrees.
Namaskar, Shubh Sandhya.
Good morning, good evening. There is a historical day in this experienced agencies NASA and ISRO. We say NASA-ISRO Synthetic Aperture Radar. We know we will be writing a new history in the international space. So, my name is Vikas Swarnakar. I welcome everybody in this lunch. I will be, Madhuri will be here. She will be commenting in English. So, we are at the Sriharikota Satish Dhawan Space Center.
GSLV F-16 NISAR Mission
GSLV F-16 NISAR 30 July 2025, 5:40 p.m. 25.
GSLV F-16 का
GSLV F-16
किया जाएगा। इस प्रमोशन मिशन का उद्देश्य है 2400 किलोग्राम वाले भूप्रेक्षण उपग्रह नाइसार को 747 किलोमीटर की गोलाकार कक्षा में स्थापित करना। इस प्रमोशन मिशन को पूरा करने के लिए
in this mission to complete GSLV the
Mk II
space
त्रिचरणीय प्रमोचन
vehicle
यान
is
है और
used.
इससे पहले यह 17 उड़ानें
Before
भर चुका
this,
है और
it
वर्तमान में
has
यह 18वीं उड़ान
done
भरने जा रहा है।
17 launches.
जनवरी 2025
This
को
year,
GSLV
29
F-15
January
द्वारा
2025,
F-15 द्वारा
GSLV
NVS-2
F-15
उपग्रह का
NVS-2.
सफलतापूर्वक प्रक्षेपण देखा
So we have
और आज हम पूर्णतः तैयार हैं,
successful launch
सज्ज
has
हैं
been
अपने
done
अगले
already.
मिशन जिसका नाम है
So next
GSLV
mission will be
S-16 NISAR
GSLV
मिशन।
S-16 NISAR mission.
NISAR is the world's most sophisticated Earth observation satellite, jointly developed by ISRO and NASA. Its 12-meter deployable mesh antenna is one of the largest in Earth observation history and uses a unique operating mode called Sweep SAR to observe Earth with a swath of 242 kilometers and a high spatial resolution. NISAR will carry L-band and S-band radars, which are designed to work independently or together. While the L-band radar contributed by NASA will work with longer wavelengths of about 25 centimeters to penetrate vegetation, soil, ice, detailed tracking of soil moisture, forest biomass, ice sheet thickness, and subsurface features. The S-band radar contributed by ISRO will operate on shorter wavelength of 12 centimeters, which makes it highly sensitive to surface characteristics. It is useful for detecting crop structures, snow cover, and fine surface deformation.
NISAR, NASA-ISRO Synthetic Aperture Radar,
NISAR, NASA
ISRO द्वारा
is
संयुक्त रूप से विकसित
this
की
is
गई
combined
विभिन्न भूकक्षा
mission.
की वेधशाला है। इसकी खास बात यह है कि नाइसार
The
दिनों में पूरे
specialty of
पृथ्वी का
this
मानचित्र तैयार कर पाएगा और पृथ्वी के पारिस्थितिक तंत्र, बर्फ का द्रव्यमान, वनस्पति बायोमास, समुद्र के स्तर की में वृद्धि,
independently
भूकंप, सुनामी,
penetrate vegetation,
ज्वालामुखी और
soil,
भूस्खलन सहित प्राकृतिक खतरों के
landslide.
संबंध में बेहतर डेटा प्रदान करेगा।
It will provide the good data.
अब आप सभी दर्शकों के सामने GSLV F-16
GSLV S-16 launch vehicle integration video will be presented.
Video of GSLV F-16 mission here at Satish Dhawan Space Center, Sriharikota. The launch campaign begins with the flag off of the nozzle end segment from its preparation building to the vehicle assembly building, where it is being handled and carefully positioned on the mobile launch pedestal. The first stage of GSLV consists of 5 solid motor segments, which have a case-bonded HTPB-based solid propellant. It has a nozzle end segment, 3 middle segments, and 1 head end segment. On your screens now is the handling of head end segment. That is the igniter being integrated on the top of the first stage motor, the interstage 1-2. It is a vented interstage to enable hot separation of GS1. The strap-on motor is called the L40s, being prepared in a separate building, handled and moved to the vehicle assembly building to be tilted and then assembled with the core motor. L40 strap-ons in GSLV. You can see on your screens it has completely been assembled.
अभी आपने प्रथम चरण का
You see first stage combination.
प्रयोग करते हैं और अभी आप देख रहे हैं यह द्वितीय चरण है
you're saying second phase GSLV Mark II.
GS2 HT कहते हैं.
We say GS2 ST.
चरण है और इसमें आप देख सकते हैं
this is the liquid propeller.
इसमें भारत पूरी तरह स्वायत्त प्राप्त कर चुका है. इसके पूर्ण परीक्षण के पश्चात
So after the full experiment,
अंतरिक्ष केंद्र लाया जाता है. आगे के परीक्षण के पश्चात इसे यान में.
So after the further experiment.
क्रायो स्टेज है, तृतीय चरण है
This is the
GSLV
cryo
Mk II का।
stage, third stage,
अंतिम चरण है
GSLV.
जो
This is the last stage,
का प्रयोग करता है,
which is a cryo fuel
लिक्विड ऑक्सीजन तथा
is
लिक्विड
used.
हाइड्रोजन का
Liquid oxygen
ईंधन
and
के रूप में
liquid
इस्तेमाल करता
hydrogen
है। यह अंतिम
will
चरण
be
है।
combinedly used. This is the last stage.
इसके ऊपर में
So on top of this,
उपग्रह को समायोजित किया जाएगा और यह है
so it will
उपग्रह
be
NISAR।
combined here.
On your
So
screens now is
NISAR.
the spacecraft NISAR. In the visuals before this, you have watched the integration of the second stage of being operated on Earth storable propellant and then the cryo stage, and these are the visuals. Craft preparation facility, the clean room where the encapsulation of the spacecraft is taking place.
पूर्ण परीक्षण के पश्चात
After the full experiment,
कर दिया गया है,
this satellite will be encapsulated.
VAB vehicle assembly building लाया जा रहा है।
So VAB vehicle assembly building has been brought after careful security and quality. It will be combined with the space vehicle.
और इस तरह पूरी तरह तैयार
In this way, fully prepared
GSLV
for this completion of the mission.
VAB से
F-16
UT की तरफ लाया जा रहा है, umbilical tower की तरफ।
towards the tower.
That's it has the movement of the fully integrated GSLV F-16 to the umbilical tower of the second launch pad.
आगे की गतिविधियां तथा परीक्षण
So further activities and the experiment will be done with the tower.
जांच यहां से पूरी की जाएंगी।
So all the health checkup will be completed here.
We are about 20 minutes away from the launch. The countdown for this mission was 27.5 hours long, and it had started yesterday, that is the 29th, at 14:10 hours here.
GSLV F-16
GSLV F-16
27.5 घंटे पूर्व
the countdown will be 27.5 have been started.
अभी आप सभी दर्शकों ने सुना, रेंज ऑपरेशन
You have seen, you have
मिशन डायरेक्टर को दे दी है।
Mission director has given the information.
उड़ान की उल्टी गिनती जारी है और
the countdown is continued
जारी है
of this space vehicle.
पश्चात स्वचालित प्रक्षेपण अनुक्रम यानी ऑटोमेटिक लॉन्च सीक्वेंस शुरू किया जाएगा।
Automatic launch sequence is going to be started.
इस दौरान यान निदेशक
In this way, the director,
telemetry tracking command
Mission Director Roger
और satellite director
satellite director are also giving the information to the mission director.
During the countdown, the servicing operations for the Earth storable propellant into the GS2 stage and the 4 numbers of L40 strap-ons was carried out. Health checks were carried out on the spacecraft and the launch vehicle. The meteorology instruments will indicate crucial data to comply to the launch commit criteria. Radars carry out transmission checks and cryopropellants are serviced few hours ahead of launch.
Mission Readiness Review Committee and the Launch Authorization Board have granted clearance to proceed with the countdown and launch of GSLV F-16 NISAR mission. All operations up to the initiation of automatic launch sequence have been completed satisfactorily. Based on the clearances received for the launch vehicle, spacecraft, range systems, ISRO ground stations, and considering the favorable weather conditions, Mission Director hereby authorized the commencement of launch operation sequence for the GSLV F-16 NISAR mission at 17 hours, 40 minutes and 25 seconds IST today, the 30th July 2025.
This is Vehicle Director. Pre-launch operations of cryo stage is authorized.
To note, Mission Director has given authorization for the launch of GSLV F-16 NISAR mission.
अभी आप सभी दर्शकों ने सुना, सभी
So all the viewers have heard
रूप से कार्य करते हुए और उनके तंत्रों की
they
जानकारी
are
मिशन निदेशक तक पहुंच चुकी है।
combinedly working.
तत्पश्चात मिशन निदेशक
The
ने
information has
ऑटोमेटिक लॉन्च
already
सीक्वेंस
been
शुरू करने का
disseminated.
अनुमोदन प्रदान कर दिया है।
So the approval has been given, and
Automatic
then
launch sequence has been authorized by the mission director. In the preceding 14 minutes before launch, a capsule of crucial functional aspects of launch vehicle systems, which includes actuation of liquid stage engine actuators, health confirmation of ground systems that are crucial for the launch, and very close to T0, control is passed on to the onboard computers.
अब हम उड़ान से 17 मिनट की दूरी पर हैं।
we are 17 minutes away from the launch.
होने के पश्चात यान को पावर
So after the countdown has been begun,
द्वितीय चरण जो है तरल
so GS2 second stage.
उसके बाद L40 चरणों में
After this
जो कि तरल नोदक पर
L40
आधारित चरण
stage,
है, उसमें भी तरल नोदक का भराव सुनिश्चित किया गया। मिशन कंप्यूटर और रडार उपकरणों की स्वास्थ्य जांच की गई। क्रायो आर्म
the health has been checked up.
में फिलिंग के लिए तैयार
Upper stage,
ईंधन का भराव
filling has
सुनिश्चित कर लिया
been
गया है।
prepared,
अंतरिक्ष
and
यान
it
को
has
पावर
been
ऑन कर
assured.
सभी स्वास्थ्य जांच पूरी की जा चुकी है। एयर ट्रैफिक कंट्रोलर तथा जल
traffic
परिवहन विभाग से भी
controllers
अनुमति
and
प्राप्त की जा चुकी है। हमारे मौसम विभाग से भी पूर्व सूचना प्राप्त की गई है और इस दौरान मौसम पूरी तरह
weather is
अनुकूल बताया गया है।
ideal for the launch.
ऑटोमेटिक लॉन्च सीक्वेंस जारी है।
Automatic launch sequence is continuous.
-16 minutes.
ऑटोमेटिक लॉन्च
Mission
सीक्वेंस
Director authorization.
कंप्यूटर
Automatic launch
hereby authorizes
जांच पूरी
to
की जाएंगी।
initiate automatic launch sequence for the launch of GSLV F-16 NISAR mission.
As DS servers activated, MC confirms data from SHAR-1 and SHAR-2.
GSLV F-16 mission at the second launch pad. It's getting ready for its first ever mission to sun synchronous polar orbit.
Automatic launch sequence initiated for GSLV F-16 and NISAR mission.
ALS in auto mode.
Tank PLO operations commenced.
नाइसार उपग्रह L और S बैंड
NISAR satellite
एपर्चर रडार वाला उपग्रह है जो उच्च विभेदन के साथ बड़े प्रमाण को प्राप्त करने के लिए CSAR तकनीक से संचालित होगा। नासा के जेट प्रणोदन प्रयोगशाला जेट प्रोपल्शन
NASA's Jet Propulsion Laboratory
सहयोग से तैयार
with ISRO. This has been prepared.
राष्ट्रीय जरूरतों को पूरा करेगा।
This not only addresses the national necessity, this will be providing the data to the whole world.
संस्कृतियों का सही सम्मिश्रण और वैज्ञानिक
It's a combination of two cultures and then the best creation.
.7-meter tall GSLV is a three-stage launch vehicle of 420.5 tons liftoff mass. The first stage, GS1, comprises of S-139 solid booster and 4 strap-ons of liquid L-40. The second stage, GS2, is Earth storable liquid stage of GL-40 HT.
L-40 EGC actuation and
The third
progress.
stage, GS3, otherwise called CUS-15, and is powered by cryogenic propellant combination of lauch and liquid hydrogen. The payload fairing is of ogive shape with 4-meter diameter.
यह रचना आपके सामने प्रस्तुत है। GSLV F-16 प्रमोचक की
GSLV F-16
7 मीटर। इसका कुल उत्थापन भार
51.7 meter the height. So its mass is 420.5 tons.
स्ट्रैप-ऑन्स लगे हुए हैं। द्वितीय चरण में L-40
the second stage
ऊपर स्टेज
L-40 and then
वाला चरण है
so this is the
और ऊपर
cryo engine stage, third stage.
पूरी तरह सुरक्षित है।
So our NISAR is fully protected.
Payload pairing 4 मीटर
Payload pairing
व्यास वाली ओजू payload pairing
4 meter.
इस्तेमाल किया जा रहा है।
TGC actuation completed.
सभी गणमान्य व्यक्ति यहाँ उपस्थित लॉन्च का अनुभव लेने यहाँ
everybody are attending, the distinguished guests.
GSLV F-16 की उड़ान दक्षिणी
GSLV F-16 flight would be from the south direction to keep it in the tracking range. Radar tracking station
मॉरिशस और अंटार्कटिका में स्थित हैं।
Antarctica,
निगरानी रखेंगे
Mauritius.
और हम तक सभी आंकड़े वास्तविक समय पर उपलब्ध
So we will be getting all the data on the real time.
We are 11 minutes 45 seconds from the launch. In the preceding several months, both ISRO and NASA have disseminated information and data characteristics to enable prospective users to take full advantage of the data gathered by NISAR when it becomes available.
होता है अपनी आंखों से
launch of this satellite.
स्वानुभव लेने वाला यह पल देखिए क्या उत्साह
of the students here at the launch view gallery at Sriharikota.
उत्साह देखते ही बनता है छात्रों का।
So the inspired students encouraged here.
पल मिला है जब
this is the moment they've been getting.
यह प्रमोशन देख सकते हैं।
Again, you can see this launch.
T-minus 10 minutes. GS2 radar engine actuation in progress.
ISRO is bringing to you a curtain raiser for the mission NISAR for your better understanding about the mission.
In an era where climate change dominates global discourse, humanity faces an increasing vulnerability to natural disasters. To address these mounting challenges, NASA and ISRO have joined forces in an extraordinary collaboration to launch the NASA-ISRO Synthetic Aperture Radar Satellite, NISAR. This groundbreaking low Earth orbit LEO observatory promises to revolutionize the way we understand our dynamic planet. Equipped with state-of-the-art LNS-band synthetic aperture radar, SAR systems, NISAR will use the sweep SAR technique to deliver high-resolution images across vast swaths of the Earth's surface. Incredibly, it will map the entire globe every 12 days, offering unprecedented consistency in spatial and temporal data. NISAR's mission is nothing short of transformative. From tracking glacial melt and monitoring agricultural landscapes to analyzing seismic shifts and managing disaster response, it will empower scientists, researchers, and policymakers with vital insights. By precisely measuring minuscule movements and colossal environmental events alike, NISAR will help us decode Earth's complex ecosystems and natural hazards. The flagship mission sees NASA contributing the L-band SAR, engineering payloads, critical systems like GPS receivers, and the solid-state recorder. ISRO is supplying the S-band SAR, spacecraft bus, and will launch the satellite aboard through its vehicle GSLV F-16 from Sriharikota. A majestic 12-meter unfurlable reflector antenna will unite the dual-band systems, enabling powerful Earth observations from orbit. The geosynchronous satellite launch vehicle, GSLV F-16, features a 3-stage configuration. Its first stage comprises a solid rocket motor at the core, support 4 liquid strap-on boosters. The second stage operates on liquid propellant, while the third and final stage is powered by an indigenously developed cryogenic upper stage. The payload fairing for the GSLV F-16 NISAR mission features a 4-meter diameter OGIV configuration. The launch will take place from the second launch pad at India's spaceport, SDSC Shar at Sriharikota. It is the first GSLV mission to be launched into a sun-synchronous polar orbit. NISAR is not just a satellite. It's a symbol of global unity, scientific excellence, and hope. It promises to safeguard our future by helping humanity live more wisely with nature.
-6 minutes.
ऑटोमेटिक लॉन्च सीक्वेंस जारी है और अब हम 6
Automatic launch sequence is continuous. We are 6 minutes away from the launch.
प्रमोशन का विवरण देते हैं
So we will give you the details of this launching.
से बना हुआ प्रज्ञान है। प्रथम चरण में
So 3 stages, S139,
है जो कि PSLV से व्युत्पन्न
which is PSLV 7.
प्रथम चरण के साथ 4
The first stage, so the liquid propeller will be used L40
द्वारा संचालित किए जाते हैं। 4 S139
gas engine
मोटर के साथ मिलकर कुल 8000 किलो न्यूटन का प्रणोद उत्पन्न करते हैं।
8000 kilo Newton.
आवश्यक होता है यान के उत्थापन के लिए।
This is required for the lift of the spacecraft.
किलोमीटर की ऊंचाई प्रदान करेगा तथा इस समय
54 kilometer height.
L40 strap on
L40 is strap on
प्रज्वलित रहता है
150 seconds.
600 मिलीसेकंड बाद द्वितीय चरण प्रज्वलित होता है और इसके तुरंत बाद प्रथम चरण के यान से पृथक कर दिया जाता है।
So it will be separated from the first.
So
again, second stage is the liquid stage.
विकास इंजन के साथ 846 किलो न्यूटन का प्रणोद उत्पन्न करता है।
846 kilo Newton.
प्रज्वलित
146 seconds. It will be ignited. 3.5 kilometer per second relative velocity. During the second stage,
क्लोज लूप गाइडेंस के अंतर्गत अपना दिशा निर्देश द्वितीय चरण की समाप्ति के पूर्व ही तृतीय चरण
after the completion of second stage, the third stage will be started. The cryogenic fuel,
और सबसे जटिल
GSLV, the third and the last stage.
चरण के पूर्ण प्रज्वलन की
In this cryo stage, the ignition
अतिरिक्त प्रणोद के लिए कमांड दिया जाएगा।
So the command will be given for 11%
क्रायोजेनिक इंजन का
additional
75 किलो न्यूटन का प्रणोद उत्पन्न करता है। इस तरह
by this way,
के साथ यान लगभग 400 सेकंड में 780 किलोमीटर की ऊंचाई प्राप्त कर चुका होगा और सापेक्ष गति 4.57 किलोमीटर प्रति सेकंड। इसके पश्चात क्रायो चरण को पुनः सामान्य प्रणोद के लिए कार्यशील किया जाएगा और फिर 400 सेकंड
after that 400 second 7.5 kilometer per second relative velocity will be applied.
की स्थितियां प्राप्त करेगा।
So it will be getting
1115 सेकंड पर पूरा किया जाएगा।
All these activities will be completed.
The launch. Let us take a quick look at the mission events for GSLV F-16 NISAR mission. The L40 strap-ons ignite 4.8 seconds ahead of T0 so that their nominal thrust can before igniting the booster. Liftoff coincides with the ignition of S-139, also called as GS-1 at T0. The burn time of GS-1 is 112 seconds and that of the L-40s is 149 seconds. By the time GS-1 and L-40s finish their operation, the launch vehicle is at 104 kilometers altitude. In a staging event typically called as hot separation, the GS-2 stage is ignited 600 milliseconds after the L-40 thrust cutoff, and 1.6 seconds later, the stage separation takes place. When the launch vehicle reaches 138 kilometers altitude, the dense atmosphere would have cleared. Since the need for thermal shielding and aerodynamic shape is no longer significant, the payload fairing is jettisoned. Closed-loop guidance also is initiated. At this point of time in the mission, the launch vehicle would have acquired 2.1 kilometers per second relative velocity. For the present mission, the burn time for GS2 is 140 seconds. It is separated 4 minutes 53 seconds into the flight. The third stage is the cryogenic upper stage, which plays a significant role in the mission. Its high specific impulse together with a long burn time of more than 13 minutes, it adds tremendous relative velocity to the CUS operation adds 376.55 kilometers
stand by for the time mark.
And increases relative velocity from 3.5 kilometers per second to 7.5 kilometers per second. An operational philosophy unique to the GSLV F-16 NISAR mission is that CUS stage is operated by 11% for the duration of 405 seconds. About 11 minutes into flight, the cryogenic upper stage shuts down. The satellite NISAR is separated injected into an altitude of 745.5 kilometers with a relative velocity of 7.57 kilometers per second.
Minus 25 seconds.
We are mere 25 seconds from the launch.
Minus 20 seconds.
सभी दर्शक हमारे साथ बने रहिए.
So please stay tuned with us.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
All L40 engines generating nominal thrust. S-139 motor ignited.
5 seconds.
That's a magnificent tracking of the GSLV F-16 NISAR mission. The deafening roar of GSLV and beautiful silhouette brightening the Sriharikota sky.
जी हाँ, अभी आपने देखा चारों हम यहाँ कंपन महसूस कर पा रहे हैं.
We are experiencing the vibration here in this mission station.
S-139 solid core motor and 4 L-40 liquid strap-ons thrusting together. 7,800 kilonewton cumulative thrust.
First stage performance normal.
Sharwan is in main auto.
The day of launch wind biasing program that is fed into the onboard computers helped the rocket to veer through the atmosphere with minimal aerodynamic loads.
प्रथम चरण का कोर बूस्टर लगभग
The first stage core booster will be ignited.
L-40 चरण
L-40 stage 150 seconds it will be calm. So after that it will be separated from the craft.
अपने अपेक्षित पथ का अनुकरण करता हुआ
First stage performance normal.
Currently the rocket is in open loop guidance. Shar ground station is tracking.
S-139 burnout.
कोर बूस्टर का प्रज्वलन समाप्त हो चुका है.
So it has been completed. The ignition of core booster
has stopped its operation. The 4 L-40s are thrusting still.
First stage performance normal.
प्रथम चरण का कार्य निष्पादन पूरी तरह सामान्य.
The first stage is normal. This is going to its launched direction. L-40 is ignited. So it will